So in this question, we're told that we have two right-angled triangles, which we can see drawn below. And we're told that given that tan of E is equal to tan of F, we're asked to find the value of X. And we're also told that we must show all of our working along the way. So just having a look at the triangles, we've got the angle E here, and then we've got two side lengths defined in terms of X. And just noticing again, this is a right angle triangle. So this side over here is the hypotenuse, and we don't have the length of the hypotenuse. Similarly for this triangle, we have the angle F, we have the right angle, and we have two side lengths, the adjacent and the opposite to this angle here. Now, the fact that it's a right angle triangle is going to come in really useful here because we're working with tan of an angle. So if we have a right angle triangle, I'm thinking back to the idea of SOHCAHTOA. So this is just how I like to remember it. So looking at this TOA part, because we're working with tan of an angle, this basically says that if we have tan of an angle, so theta for example, this is going to be the O for opposite divided by A for adjacent side. So tan theta is equal to the length of the opposite side to the angle theta divided by the adjacent side. And I can just look at these triangles above, and we're working with, so tan of E firstly, the side opposite this angle is going to be this side over here, so length X, and the side adjacent to this angle is this side here, so length 4x minus 1. Just making sure we don't get confused with the hypotenuse here, which we're not looking at. We're just looking at the side that's adjacent to the angle and not the hypotenuse. So we have the opposite and the adjacent. And similarly over here, opposite to angle F and the adjacent to angle F there as well. Now what we can write out is tan of the angle E this time. So tan of E is the opposite over the adjacent. So tan of E is equal to X over 4x minus 1. And we can do tan of F as well, because that's what we're looking to kind of find here, so we can get an equation in terms of X. So tan of F is the opposite over the adjacent, so 6x plus 5 divided by 12x plus 31. Now what we can do, because we have this expression here, we're told this, we can make them equal to each other. So tan of E, which is x over 4x minus 1, is equal to tan of F. And we now have set up an expression which is just in terms of X. So we can solve this to find the value of X, which is what we need. So we need to solve this equation that we have here. And we're working with fractions, which is not the best. So we're going to start a process to remove these fractions. Now we basically just need to multiply up both sides of the equation to eliminate this fraction. And how we can do that is kind of by cross-multiplying them, or by multiplying both sides by the denominator 4x minus 1 and this denominator of 12x plus 31. So if I just take this as multiply by 4x minus 1, so that's going to cancel out the denominator of the left-hand side, and multiply it also by 12x plus 31 to cancel out the denominator on the right-hand side. So if we multiply the left-hand side by this, when we multiply it by 4x plus 1, it basically cancels out the denominator, but then we still need to multiply x by 12x plus 31. So we have x lots of 12x plus 31, and that's going to be equal to 6x plus 5 multiplied by, again, 4x plus 1, 4x minus 1, sorry, and also this 12x plus 31, but that cancels out with the denominator. So it's kind of like we're cross-multiplying here, so we're multiplying this by this and that by that, so there's a cross here. So now that we have this expression, we can expand the brackets and expand the left-hand side and come up with another equation in terms of x. We're just expanding everything so that we can then look at how many x squared terms and x terms we have and see if we can solve for a value of x. So if we multiply x by 12x, we get 12x squared plus 31x, and that was just by multiplying x by 12x and x by 31. And that's going to be equal to the expansion of these brackets, and I like to use the FOIL method. So firstly multiply these two. 6x times 4x is 6 times 4, which is 24, and then x times x, which is x squared. And then we can do this one and this one. So 6x times minus 1, I'm going to do minus 6x. Now moving on, we have 5 times 4x, and that gives us 20 plus 20x. And then finally, we just do this last one. 5 times minus 1 gives us minus 5. We can now simplify this down further and collect like terms. So it's just leaving the left-hand side the same. That's equal to 24x squared minus 6x plus 20x just gives us plus 14x minus 5. And we can now collect the terms further. So we can subtract 12x squared from both sides, and we can subtract 31x from both sides. So if we subtract 12x squared plus 31x from both sides, we're going to get 0 is equal to 24x squared minus 12x squared, so 12x squared, plus 14x minus 31x, and that's going to give us minus 17x minus 5. So now we've got an equation equal to 0. And that was just by subtracting 12x squared plus 31x. So we have this equation equal to 0. And we can now find a way to solve this quadratic equation to find the value of x. Now we can do this in a couple of different ways. You could substitute it into the quadratic formula, or alternatively you can factorize it. So factorizing this expression, it actually factorizes as 4x plus 1 multiplied by 3x minus 5, and that's equal to 0. So the way that I'd do that is by looking at factors of 5 here, well, minus 5. So we either have 1 and minus 5 or minus 5 and 1, because there are no other factors of 5. And then we also need something that multiplies to get 12, being with the x terms. So 4 times 3 gives us this 12x squared that we have here. So then you can just try a few different methods and see what will work, and this is the factorization that we come to at the end. So then we now know that one of these brackets has to be equal to 0 for the left-hand side to be equal to 0. So if we have 4x plus 1 is equal to 0, 4x is equal to minus 1, x is equal to minus a quarter. However, we originally had a side length which was x, and you can't have a negative length, so we know that x cannot be equal to minus a quarter. So now looking at the other bracket, 3x minus 5 is equal to 0. Add 5 to both sides, 3x is equal to 5. Divide both sides through by 3, x is equal to 5 over 3. X is greater than 0, so it can be a side length, a real tangible side length. So that is the correct answer here. And there we have it, we've calculated the value of x. So as for how the marks are awarded here, the first is for a process to derive an equation in x. So for deriving this equation that we have here. Then for a process to remove the fraction, so by cross multiplying out and getting this equation here. The next mark is for them reducing it down and multiplying the terms out to get this quadratic equation here. The next mark is for factorising it and setting it equal to 0, or for using the quadratic formula. And then the final mark is for the correct final answer of x equals 5 over 3.